Welcome back, everyone. Here we are where we left off last time. In part 1 of our DataFrames lectures, we learned how to actually grab information from the data frame based off a column location or a row location or both. Now what we're going to do is learn how to grab information off a data frame based off a certain condition. Here we have our original data frame with columns W, X, Y, Z and rows A through E. Now let's imagine I wanted to maybe grab the subset of the data frame where we only had positive values. Well, one way we can do this is by asking, where is the data frame greater than 0? Essentially, performing a comparison operation across the entire data frame. What happens is we get a data frame back. However, this is now a data frame of Boolean values, where we get true, where the condition is true, so we have a positive number, or false, where the condition is false, so we have negative numbers there. If we were to use this as a filtering condition, basically passing it in to the data frame as a condition, what happens is Pandas removes all the values that happen to be false. So we get these not a numbers, or basically missing data. Then what we could do is later on learn about how to work with missing data and remove those values or fill them in with something else. Now typically, these columns in our data sets are going to represent features, and we're going to want to filter based off of those features. So for example, if we take a look at our original data frame, I have data frame with the columns W, X, Y, and Z. Let's imagine I wanted to filter out my entire data frame based off conditions occurring in X. So I wanted to grab where X happened to be greater than 0. If we take a look at this, it gives us back a series where we have the index values A, B, C, D, E, and the corresponding booleans that happen to correspond with this statement. So we can see that X is negative on B and D, so we get a false there. And what we do is we can take this condition and essentially broadcast it across the entire data frame based off these index locations. So what it ends up doing is it only returns back the true rows. So we should only get back rows A, C, and E if we take this condition and pass that into our data frame. And this is very, very common with Pandas. We're going to be doing this sort of thing all the time. So if there's one thing you get out of this section is understanding conditional selection of Pandas. If we go ahead and run this, here we get back the data frame results where X was greater than 0. Now keep in mind, we can also now work off of this data frame. So since this itself is a data frame, I can then perform operations such as grabbing a single column, like the W column off of this. And I get back here the W column off of the data frame where X is greater than 0. And I can do all sorts of things just as I would any normal data frame, like grab the very first integer location row, which would be these values here. So keep that in mind that it's really common to see Pandas operations stacked on top of each other in one giant long line. Now I can actually select with multiple conditions. Here we're selecting on the singular condition of X being greater than 0. But what I can do is have two conditions. Maybe I want where dfw is greater than 0 and where dfy is greater than 1. So how do we actually combine these conditions with Pandas? Well, there's a couple of steps. The first step is to write out the conditions you want to search for. So here I have my first condition where w is greater than 0 and my second condition where y is greater than 1. Step number 2, which beginners often forget, is to wrap each of these in parentheses. Then once they're wrapped in parentheses, you have to decide if you want the actual filtering to be done with the AND operator or the OR operator. So the AND operator is an ampersand, which is essentially Shift 7 on the keyboard. So here we can see that I'm asking for results to be returned back where both of these happen to be true. So this is an AND. If I want it to be returned back where either of them happens to be true, I can use this pipe operator or the OR operator. Let's go ahead and stick with ampersand because that's usually the more common of the two that we're using. And then we pass this entire thing into the data frame. And if you're a beginner with Pandas and you see this giant line of code, it can be pretty confusing at first, but just break it down into its key components and it will begin to make sense. All we're doing is we're asking where df of w is greater than 0, wrap that in parentheses, and we also want the condition where dfy is greater than 1 to be true. We take both of those, connect them with either the ampersand for AND for both conditions to be true, or a pipe operator for either condition to be true, and then pass that into our data frame. If we were to use the pipe operator, well, it looks like all the values in the data frame satisfy either this condition or this condition. However, only these happen to satisfy both of these conditions. And this is the exact kind of thing we're going to be seeing all the time with Pandas. Now, a couple of more index details I want to go over is how to reset the index in case you have a named index but you want to reset it to integer values. If we take a look at our data frame, let's imagine that here I have this named index, but let's imagine I actually wanted it as a column itself. What I can do is say reset underscore index, run that, and it will actually create a new column for me called index with these old index values. And now the new index, notified here in bold, are just integer values 0, 1, 2, etc. Keep in mind, this is not permanent unless you actually assign it that way. So what I want to show you now is how we can take a column that exists already and set that as our index. So I'm going to create a list called new ind for new index. And what I'm going to do here is pass in some states. Keep in mind it's going to have the exact same length as the number of rows we currently have in our data frame in order for this to work. So we'll go ahead and say California, New York, Wyoming, Oregon, and then Colorado. So we have our new index list, and what I'm going to do is assign this as a new column by calling the column as if it already exists and then setting it equal to this new index. So here we have our data frame. Recall that we actually didn't make this resetting permanent. If we wanted to make it permanent, we would say df is equal to df.resetIndex and do the reassignment that way. But for right now, I still want that old index. So let's imagine here that I actually didn't like this labeled index. It wasn't useful to me, so I didn't want to save it. And instead, I wanted this states column to be the index. What I can do is instead of resetting my index, I call df set index and then pass in the column I want to set it to, such as states. And then when I run that, it gets rid of your current index. Keep in mind, it won't save it to another column. If you just call set index, it'll completely remove it. And then it'll take your old column, here states, and then turn it into an index. Something that confuses students is they think the word states here is actually a column name. That's actually not true, and it's denoted by the spacing. Notice that W, X, Y, Z are on their own line, and then a line below it we see states. Basically what this indicates is that states is the name of this index. The only columns we currently have here are W, X, Y, Z. Keep in mind, if I say just set index, this effect is not permanent unless I actually do the reassignment. So if I want the reassignment to occur, I can say df is equal to df.setIndex, run that, and then I get back this data frame, permanently changed so that states is the name of the index. To confirm that W, X, Y, Z are the columns, I can say df.columns, and here I only see W, X, Y, Z. Notice I don't see states because states is just the name of that index now that I've set it. By default, indices usually don't have names, which is why you see everything here on the same line. Finally, there's a couple of data frame summaries that are really useful, such as df.describe, which essentially just gives back a bunch of numerical information. So it provides summary statistics for each column, such as the count, each of these has 5, the mean, the standard deviation, the minimum value for each column, the maximum value, and then the percentiles. So the 50th percentile, that's essentially the same thing as the median. Essentially saying 50% of all points are below this number, 50% are above it. The other ones that are useful are df.info, telling you how many not nulls and the data types. And if you just want the data types, you can also say df.dtypes. Okay, that's it for this lecture. Make sure you review that notebook carefully because conditional selection by Pandas data frames is something we're going to be using all the time throughout the course. Thanks, and I'll see you at the next lecture.